right, we are going to cover 7.3 here. Um, more formulas. So let me show you. I went ahead and put a trig formula sheet here for you guys on Canvas. So if you click on it, you'll see this sheet here. You can download it onto your computer if you want to. It has pretty much all the formulas and identities that we are covering. It has a little bit of extra, that periodic formula there on the bottom left. Let's see. That one I didn't give to you guys. Let's see. What else? We did the cofunction. So we're pretty much doing the double angle formulas today, the half angle formulas, product to sum to product, all in this section 7.3. Okay. So you're allowed to use this sheet when you take the test, and when you do your homework. It might be a little easier to have them all in one place. Okay, so feel free to use this. Okay, there is one set of formulas right here. Your book uses the ones here on the left for the half angle, and the sheet has these extra ones here, an alternate form. I'm going to kind of go over these here, these formulas here, because if you can see here, it says plus minus. Okay, so it's not that you have two answers, a positive answer and a negative answer. It's going to be plus or minus, and you're going to have to decide which answer to choose, the positive or negative. Okay, and that's going to depend on where your angle lies. Okay. All right, so let's go ahead and take notes. Okay, so 7.3, and this deals with double angle, half angle, and product sum. Okay. All right, so I will not write all of the product sum formulas here. I will do the double angle. I'll put them here so that we can just look at it as we do the examples. Okay, so sine of 2u is equal to 2 times sine u cosine u. Okay, tangent 2u is equal to 2 tangent u over 1 minus tangent squared u. And cosine 2u is, you'll have three choices. You can use this one, cosine squared u minus sine squared u, different from the Pythagorean identity. So you can use that one. Or you can use this one, 1 minus 2 sine squared u. Or you can use this one. Okay, and both of these on the bottom here are derived from using the Pythagorean on that first one. Okay, replacing cosine squared or replacing sine squared. Okay, so I'm going to leave that one up, and I'm also going to write down the half angle formula. And that's the one that I kind of want to pay extra attention to. Okay, so we have one for sine. half angle, and that is going to equal positive or negative, not both, positive or negative square root 1 minus cosine u all over 2. Okay, and same thing with cosine of a half angle. That's going to be equal to plus or minus, not both, of 1 plus cosine u over 2. And then tangent, we don't have to worry about that plus or minus. Okay, so tangent of a half angle is going to equal, and you'll also have two choices here. You can use this one, 1 minus cosine u over sine u. And when you plug in, you'll get the correct sign. Whereas for sine half angle, cosine half angle, you have to determine the sign. Okay, so you can use this one for tangent half angle, or you could use this one, sine u over 1 plus cosine. Okay. All right, so put a little note here for these two. Very important. Okay, the plus minus depends on the quadrant in which your half angle lies. Because remember, sine is positive in quadrants 1 and 2, but negative in quadrants 3 and 4. Cosine is positive in quadrants 1 and 4, but is negative in quadrants 2 and 3. Okay, so depending on where your half angle lies. Okay. All right, so let's take a look. So let's just do some basic right triangle trig. We're not even in a quadrant or anything. Okay, so suppose you're given this right triangle. Okay, so there's our right triangle. Okay, and suppose this is our angle that we're talking about. Let's just do a basic 3, 4, 5 triangle for simplicity. And suppose that you are asked to find, let's do sine 2 theta, cosine 2 theta, and tangent 2 theta. And then we'll also find the half angle. So we'll do sine theta over 2, cosine of theta over 2, and tangent of theta over 2. Okay? All right, so let's start with the double angles. Okay, so starting with sine 2 theta. Okay, so if we look just at the very beginning here of the notes, the sine of 2 theta, right? That's just going to be 2 sine u cosine u. Okay. Okay, so that's going to be 2 sine theta cosine theta. And we know what sine theta is. Sine of this theta here in our right triangle is opposite over hypotenuse. So we're going to get 2 times opposite over hypotenuse is 3 over 5. cosine is adjacent over hypotenuse, so that's 4 over 5. Okay, and this will give us 24 over 25. Okay, let's do cosine double angle. Okay, if we look at the formula at the very beginning of your notes, we have, you know, 3 choices there, I think. Let's take a look. Okay, so cosine, we've got those 3 choices. I know what cosine and sine are off of my right triangle, so I'm just going to use that first one. Again, it doesn't matter. Okay, so cosine squared minus sine squared. Okay, and from my right triangle, I see that cosine, again, adjacent over hypotenuse, so 4 over 5. And sine squared is 3 opposite over adjacent, so 3 over 5. Okay, so we get 16 over 25 minus 9 over 25. And we get 7 over 25. Okay, and let's do the third double angle tangent. Tangent 2 theta. I'll just use the 2 tangent. You also have, no, we just have the 1. Okay, so going back up here, we have that one formula, 2 tangent over 1 minus tangent squared. Okay, so 2 tangent over 1 minus tangent squared. Okay, so we're going to get 2 times. If we look at the right triangle, tangent is opposite over adjacent, so that's going to be 3 over 4. So 2 times 3 over 4, 1 minus 3 over 4 squared. Okay. So here in the numerator, the 2 and the 4 will cancel, leaving me with 3 over 2. And down below, I will get 1 minus 9 over 16. Okay. So here, different ways to go about this. Okay, so we can do 3 over 2 over 16, 16 minus 9 over 16. Okay. That looks like a 4. Okay. So we get 3 over 2. And then here we get 7 over 16. Okay. And different ways to do this part. You could clear your fractions by multiplying by 16, the numerator and the denominator. That's one way to do it. Or you can treat this like a division problem, 3 halves divided by 7 over 16. It's up to you, depending on what you learned, how you learned this. Okay, so I'm just going to go ahead and clear my fractions here. So I'm going to multiply by the LCD, which is 16. And that will cancel there. And that will cancel here. Okay, And that will leave me with 24 over 7. Okay. All right. So we did the double angles. So now let's go ahead and do the half angles. And we'll do it over here on the side. Half angles. Okay. And let me just kind of do this. Okay, so let's go up to the top, and we need to find sine of half angle, cosine half angle, tangent. All right, so sine of the half angle equals, this is the one with the plus minus, okay? So here we're just doing right triangle trigonometry, so we don't have to worry about what quadrant we're in. Everything's going to be positive, okay? So we're going to take the positive answer, and it's 1 minus cosine theta over 2. Okay, so we just have to plug in for the cosine. So it's going to be positive 1 minus, and here cosine is adjacent over hypotenuse, which is 4 over 5, all over 2. Okay, and same thing with what I just did with that tangent double angle. I'm just going to get rid of my fraction. If you could get rid of the fraction right now by multiplying everything by 5, including that 1. Or if you want to do the subtraction first, that's fine too. So if you do 5 over 5 instead of 1, you do 5 over 5 minus 4 over 5. That's 1/5. And now you can go ahead and get rid of your fraction. Like I said, you could have done it in that previous step. Okay, so, oops, 5. So my LCD is 5, so I'm going to multiply both the numerator and the denominator by 5 to get rid of my fraction. Okay, and that will leave me with a positive answer. And here we get 1 over 10. Okay. All right, let's do cosine. Cosine of half angle. So again, take the appropriate sign. We are not in any particular quadrant, so we will take the positive square root, not the negative. Okay. And it is going to be 1 plus cosine theta over 2. And we already saw that cosine theta is 4 over 5. Okay. I see it from this answer from sine theta. So 4 over 5 all over 2. Let me make this a little bit more clear. So it's over everything. Okay, so again, you could do the 5 over 5 instead of the 1. 5 over 5 plus 4 over 5. I'm just going to go ahead. I'm not even going to do that. I'm just going to go ahead and multiply everything by 5 to get rid of that fraction. Okay. All right, so then that leaves me with square root of 5 plus 4 all over 10. So that leaves me with square root of 9 over 10. Okay. You could simplify that. Square root of 9 is 3, right? And then just leave the square root over the 10. Okay, not sure what WebAssign is going to ask you for. Okay, and let's do tangent of the half angle. Okay, so tangent of the half angle, I will use this one, 1 minus cosine theta over sine theta, since I know what cosine theta will be and what sine theta will be. Okay, so here I have 1 minus, cosine theta is 4 over 5. And then sine theta is 3 over 5. Okay, so you could either do the subtraction right now, 5 over 5 minus 4 over 5, or you could just get rid of your I call them minor fractions. Okay, so I can multiply everything by 5 to get rid of these minor fractions here. And then that will give me 5 minus 4 over 3, which is 1/3. Okay. And with the tangent, we don't have square roots or anything, so we don't have to worry about plus or minus square root. Whatever sign you get there, that's the sign. Okay, let's take a look. Let's look at this example. Let's use a double angle to rewrite six cosine squared x minus 3. Okay, so I'm going to write that down here. 6 cosine squared x minus 3. All right, so first of all, when I look at this, hopefully you are looking at this and you see that, oh, they both have 3 in common. So let's factor out the 3 and then see what we get. 3 times 2 cosine squared x minus 1. And right there, that 2 cosine squared x, that's our double angle for cosine. So I can rewrite the part that's inside the parentheses as cosine double angle. Okay. And let's go ahead and take a look at another example. So let's take a look at half angle, double angle. Let's do a double angle problem inside a quadrant. Okay, so let's take a look. Find the exact value of tangent to u given that cosine u equals, I'm going to put the negative right in the middle so you don't know which number is negative, the 2 or the 3. And u is between pi over 2 and pi. Okay, so lots of clues here. Okay, so first of all, we need to find the exact value of tangent of 2u, right? So tangent of 2u, we have a formula for that, is 2 tangent x over 1 minus tangent squared. I need to use some u's here. Okay, so we have this formula, right? So we need tangent u. Okay, we don't have that. We know cosine u, but we don't know tangent u. Okay, so let's go ahead and draw. Okay, so u is between pi over 2 and pi, so that's quadrant 2. So let's go ahead and draw our angle here. Okay, so this is u. I'm going to call this u prime. Okay. And then I have my right triangle. And I know that the cosine, which is adjacent over hypotenuse, is negative 2/3, right? So adjacent, hypotenuse, but one of these is negative. Okay, which one should be the negative? The 2 or the 3? Okay, hopefully you said the 2 because that's the x value. The r, the radius, is never negative. Okay, so we have that. Okay, so I can find this value, this y value here, using Pythagorean. Okay, let's go ahead and do that. So y squared plus negative 2 squared equals 3 squared. So y squared plus 4 equals 9. Y squared equals 5. Okay, so y equals square root of 5. Okay. All right, so then now I know what tangent is. Okay, we know tangent is opposite over adjacent, so that's going to be square root 5 over negative 2. Okay, so let's go ahead and finish this formula. So tangent of 2u is going to be equal to 2 tangent u over 1 minus tangent squared u. Okay, so let's fill this in. Tangent u is opposite over adjacent, so square root 5 over negative 2. So we get 1 minus, and then we're going to do negative square root 5 over 2, quantity squared. Okay. So here, my 2's will cancel out up here. So I will have negative square root 5 in the numerator. And then down below, when I square that, I'm going to end up with a positive, and I'll get 5 here and 4 here. Okay. And again, if you don't like that minor fraction there, that 4, you can, at this point, clear your fractions by multiplying everything by 4. To get rid of it. Okay, and that will leave me with negative 4 square root 5. And then down below, that will leave me with 4 minus 5, which is negative 1, right? Which is going to leave me with just positive 4 square root 5. Okay? All right, so that is about it. So if you have any questions with any of this, just email me or send me a message.